of these, and that's excellent all the way. Jordan?
Did I have my happy meal?
Yeah, you ain't getting no Happy Meal. You didn't get it right.
You got everything correct. Well, I got questions though.
I
don't think you did.
Yeah. Got everything correct.
I most definitely did not.
Now, these first few, it says tell whether each polynomial is completely factored. If not factored. Now, if you didn't do it, I'm still calling on you, so don't just sit there and check out, because you gotta know how to do this. All right, so you gotta examine it and say, is it factored? Can it be factored further? Why or why not? Okay, as you take a look at that. Come on, the first one. It is completely factored. And I'll give you a hint. Out of those 6, 4 of them are completely factored. Okay, you don't have to do anything else. So that one is done. 9x squared plus 1 has 2 terms, but it's a plus instead of a minus. So that's all you got. That's completely factored for that one. So number 2, Sam, what do you think about that one?
I think you should divide all sides by x.
Okay, it is not completely factored. You can take out an x. All 3 terms in the side, the parentheses, have an x in common, so it means we can take additional x out. So what would my answer look like, Sam?
I got 2x equals 4x squared minus 3x minus 8.
All right, good. That x now comes out with the 2. You pair it with the 2, and so you put 2x, parentheses, 4x squared minus 3x minus 8. Okay, for that one. Connor, what's your gut tell you for number 3? Is it completely factored or not?
It is completely factored.
Okay. What is it?
This is all confusing to me. I don't know.
Okay, well, that's why we do this. Right now, here's what you're looking at. You're looking at this, and you're thinking to yourself, all right, is that factorable? Does that fit any of those cases we've done earlier? Does it have a GCF?
It does, maybe.
All right, now this you got to look. Does the 4 and the k cubed have anything in common?
No.
So it has no GCF. Okay, so you don't make it harder than it is.
Gotcha.
Now the only thing it could be, what could this be? What could it be that we've done that has 2 terms? Josh.
Perfect square.
Perfect square. Now, and we call that a difference of squares, but I know exactly what you're saying. And we did things like x squared minus 9. We said that's x minus 3, x plus 3. You could do 4 minus x squared. That would be 2 minus x times 2 plus x. If both terms are squares, then you can factor it into a difference of squares. But k cubed is not a square. If it was k squared, we'd have something different. But since it's k cubed, we don't have anything, and this is completely factored. So if you put that down, whether by luck or knowledge, completely factored is the right answer. Okay. But you got to understand, what are you looking for? And some of you are there, some of you are not there yet. So on number 4, what are you looking for? All right, as you take a look at number 4 to say whether it's completely factored. Morgan, what do you think?
I said it wasn't completely factored.
What made you say that?
Because 2x and 3 don't have a GCF, and neither do 3x and 5.
Good. No GCF here, no GCF there. They're not a difference of squares, completely factored. Completely factored. Okay, so you're done. You're done. All right, how about number 5? Colin. Is that completely factored? Can it factor further? Is there GCF? Is there GCF? Between that those highlighted terms.
1?
All right, we never use 1 as a GCF. It would have to be something other than 1.
No.
No. Okay. You have 2 terms, right? you got a minus sign in between it. If you have two terms and you got a minus sign, that is where you want to at least look at a possibility of a difference of squares. Can this one be a difference of squares? Yes. What does it factor into? What squared gives you 4p to the fourth? Evan?
2p to the second.
2p to the second times 2p to the second. Now, 1 tends to throw people off. What squared gives you 1? Just 1. 1 times 1. You got to make it a minus 1. You got to make it a plus 1. So this is going to be 4. Whoops. Let me go back here. 4. 2p squared minus 1. 2p squared plus 1. Okay? 2p squared minus 1, 2p squared plus 1. That last one is a difficult one. It is completely factored at this point. Okay, so if you put that down, you're good. Completely factored for that last one. All right, now 7 here through these other ones. You just had to do the odds. Most of these factor more than one time. Now we're getting to the point where something else happens. Okay, thank you. All right, Amanda, 7 has a GCF, what would it be? There's going to be a constant in front of it. 3x to the third power. So 3x to the third, 3x to the third. So 3x cubed, what do I get when I divide by that? I get x squared minus 4. So if you had that down, you're good, but we're not done. Why aren't we done, Preston?
Because it can still be factored in.
And how can we factor it further?
You have to separate or divide the 4 minus x squared by 2.
And what's that become?
X minus 2.
Good. This is a difference of squares. It becomes x minus 2, and then what?
X minus 2.
No, not x minus 2 again.
X plus 2.
X plus 2. Make sure your signs are different. Make sure your signs are different. All right, Jay Lee, for number 9. What you got?
Divided by 2p.
Good. Very good. You divide them by 2p. That is the GCF. And then you put 2p on the outside. Then what else? Then what do you got?
4p plus.
Those p should cancel. It should just be 4q squared. What'd you have for your next term?
Plus 4q.
Plus 4q. And what'd you have for your next term? Plus 1. All right. Good. Did you stop there? All right. So now it goes again. Did anybody else factor it further? Nobody else? All right. I tell you, this is one of the harder homework. So that factors again. All right. Stop. Take a look at it.
Oh, I did.
Colin?
2q plus 2q. Oh, I don't know how to do that actually.
Okay. You now just basically look at this as a whole new problem. Okay. And you get is it a difference of squares? No, because there's not 2 terms. There's 3 terms. So this is where we do the grouping. We take the first 4 times 1, which is 4, and I look for 2 numbers that multiply to 4 and add to 4, and those numbers are 2 and 2. And so this is where we do 4q squared plus 2q plus 2q plus 1, and then I group. And so I take out a 2q here, which gives me q plus 1. This one we use 1. So I end up with 2q plus 1 times 2q plus 1. So if you were given that problem by itself, that's what you would get. Now, hold on here. So the 2p stays on the outside.
At this time, we would like ninth graders that are having their spring pictures taken, last names starting with A through M. Please go to the main gym now if you are having your spring pictures taken. Ninth graders with last names starting with A through M. Thank you.
Not a lot of spring pictures this year. All right, so that's what you end up with. Now, if you left it as 2q plus 1 times 2q plus 1. All right, so that's a hard one. That is a hard one because you got to do multiple things, and the second one is not an easy one. All right, how about 11? Christian, take a look at 11. GCF.
MN.
Good. MN, and what do we get when we divide by MN?
N to the fourth minus N to the second.
All right, excellent. But we're not done. We are not done. Allie, do you know what we would do further? Divide them by 2? Only if those are constants. Those are exponents. So think here. If you got two terms and you got a minus sign, think about that difference of squares. Difference of squares. So this now, mn stays in front. N to the fourth, I can make n squared minus m, and then I can make that n squared plus m. So this is, like I said, you factor once, but you're not necessarily done. Okay. So that would be that answer. And let's see. And then you're done with that one. Whoops, hold on. 13. All right, Zane. What'd you do for 13?
Divide everything by 3x squared.
All right, good. 3x squared, 3x squared, and 3x squared. So what's that give us then?
2x squared.
Okay.
And then negative x.
Okay.
And then negative 3.
Okay. That's a good step. Now, Zach, is he done?
No.
What's he still got to do?
I'm trying to figure out what to do. Oh wait. You need to split the x.
Okay, this is now where we have 2x squared minus x minus 3. That's a whole nother problem. That's just a problem where we're doing the 2 times negative 3, which is negative 6. And what are two numbers that multiply to equal negative 6 and add to get negative 1? And what are those two numbers, Zach? Or you might have done guess and check.
Yeah, I did that.
All right, Allie, what are those two numbers? Positive 2 and negative 3. I'm going to use the negative 3 first. And so I can take out an x here, and I get 2x minus 3 plus a 1, 2x minus 3. And so now I still have my 3x squared. You're going to have a 2x minus 3 times x plus 1. That'll be your final answer. Final answer. So you got to do everything twice. You got to know how to do GCF, then you got to know how to do all the other little pieces. And now this last one is 4 terms, so you do grouping. Take out a p cubed, and I get p squared plus 3. I make that a 1, gives me p squared plus 3. And so I'm left with p squared plus 3 times p cubed plus 1. That's what that one's going to end up being. That one just by grouping, so you got that. All right, here's what I want to do. Just write on your homework. Keep your homework out. Do these two problems. Do these two problems. Number 1 has a GCF and then it factors again. Number 2 does not have a GCF. That's just a good old-fashioned trinomial. See what you come up with for those two. You need to be able to do those two. So take out a GCF and see if you can factor it again. And then number 2, multiply 6 times 12 and then kind of go from there. See what you come up with. Now I'm going to hand you this sheet that we're going to do next. While you're finishing that.
Oh, come on, Joe. Come on, Joe.
Okay, now that'll factor in, that inside part. What are you doing there, Martin? You stuck?
Yeah, kind of.
Oh.
Yeah, wait.
Doing
I don't understand this. Going from the simplified to simplified more.
Oh, yeah? Okay. All right, so for the first one, what's the GCF? Jordan?
First one, GCF would be 2.
2.
And also, for the second one, how do you find the add? Like what you add?
All right, we'll get to that one. So I take out the 2, I'm left with y squared minus 2y minus 15. And a lot of you are right there. And I didn't get a chance to look at everybody to see if anybody got it. But it goes further. Okay, the y squared minus 2y minus 15, that is a trinomial that we've done over and over and over again. And a lot of you got 100% on the quiz that we took over that. What do you look for? All you look for is 2 numbers of what? Multiply to get negative 15 and add to get what? Negative 2. What are those 2 numbers?
-5 and 3.
Negative 5 and 3. So this is y minus 5 times y plus 3. So you're just redoing a problem we've already done lots of time. So y minus 5 times y plus 3. Okay. Now, does number 2 have a GCF? No, doesn't have a GCF. So we got to go back to just our normal rules for this one. It's a trinomial. Our rules say to multiply 6 times 12 to get 72. And we say what multiplies to equal 72 and what adds to equal negative 17. Well, whoever has it. Anybody got it?
-8, -9.
It says -8, -9. They both have to be negative. All right, now what do I do with that -8, -9? He's correct. What do I do with that -8, -9? Okay, this is where we do this. We make it 6x squared minus 8x minus 9x plus 12. Okay, and now you do a GCF for each one. So we do the factor by grouping. Okay. And so I'm going to divide, what's my GCF there? 2x. And if this is a negative, make sure that's -3. And when I divide by 2x, I get 3x minus 4. Divide by -3. I get 3x minus 4. And this was going to end up being 3x minus 4 times 2x minus 3. Okay. We've done that before. That was on that 83 to 84 quiz. All right, I handed you a worksheet. Now, there's not enough room to do your work on there. That's just for your answers. Keep your notebooks out. All right, we're going to split a little bit. Okay, we're going to split a little bit. If you have an A in a class, and actually you're going to do 1 through 18. You're just going to go through them. And actually, I'm going to tell you what to do. And actually, you're going to go over to Mrs. Wolf's room. You're going to work together. So I'm going to send, it's going to be Colin, Sam, Zach, okay, Amanda, and Hanan. I think for right now. You guys go over there. Preston. Now, here's the deal. I want you guys all to have the same answers. What that means is work together to figure these out. And we'll be over there about every 3 or 4 minutes, or every 5 or so minutes to see where you're going. So you guys go ahead and take your notebooks.
I just read the board.
And you're gonna go over there. What?
I'm close to it.
You're staying here. I know where you need to be. Okay.
Is that a bad thing?
Not a bad thing.
I'm just kidding.
We have to be
That's what okay. If you have below an A, then this is where you gotta pay attention, because I'm helping you out a little bit. You're gonna do 1 through 4.